Hello and welcome to the video that's going to finish off section 2-1, quadratic functions. Here in example 4, it says we're going to write a quadratic function, and the directions say write the standard form of the quadratic function, whose graph is a parabola with vertex at 1, 2, and passes through this point, 3, -6. Now, what they've given us here, remember when we're dealing with circles and parabolas, the vertex here is a special point, and that 1, 2 can also be h, k. Oops, k. Any other point, again, the center of a circle and the vertex of a parabola are so special. They get those new letters h's and k's, but here's just a general point, and that's x, y. Now, if we look at our equation, the standard form in its purest all variable form, we get f of x equals some number a times quantity x minus h squared plus k. And let me put on the other side of this equal to. Remember, f of x is the same thing as y, because we put an x value into a function. That would be our f of x, and what pops out of that is our height when we want to graph it, or our y value. So f of x equals, here's our parabola, and that's equal to y. So let's see here, I'll sort of color code this. H and k, that's our center or our vertex of our parabola. So the h is going to turn into a 1, the k is going to turn into a 2. So this h is going to be a 1, and this k, we can keep the plus, that's going to be a 2. Now we've got a point here, x, y, 3, -6. So I can take out this x and make that a 3. So this becomes 3 minus 1 in the parenthesis. Don't forget we still got an a out here. And our y value is -6, so we can set this equal to -6. So when we took our standard equation and we plugged in the h and the k and the x and the y, notice the only thing we have left, this a value. So when we solve this, that's what we're solving for, a. So this becomes a, and let's work here in the parenthesis. 3 minus 1 is 2, and then we square that. 2 squared is 4, so I can write that as 4a plus 2 equals -6. And then we're almost home for this part. To get the 4a alone, we're going to subtract 2. So 4a equals -6 minus 2 more is -8. And then if we divide by 4, -8 divided by 4 is -2. So let's go back and read the directions again. Write the standard form of the quadratic, given this blah, 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 passes through the point. Okay, so what we were looking here, again, I'm going to just rewrite the entire blank standard form. F of x equals a x minus h quantity squared plus k. They gave us the h and the k. That was pretty important right at the beginning, h and k. And now we've found the a value. So we can write our final answer, our standard form of this parabola, f of x equals, it's no longer just a, it's now -2. X minus, here we put in the h and the k, so this will be our x minus 1 quantity squared, plus the k value was 2. All right, let me get rid of the blank one. And there we go. So again, what we did is use the standard form, plugged in the points to solve for the a value. Now we're rewriting it. Notice in your final answer, there's always going to be an x. F of x is equal to this, and it's defined in terms of x. You don't want to put the x value into that 3. We only use this point to solve for a. Once we found a, we can throw that point out. We don't need it anymore. Okay, let's see here. I'm rereading the directions. They did not ask us to graph it, but here's what that would look like. Our vertex is at 1, 2. Our parabola opens down, and it goes through that point 3, -6. A practice problem for you, same song and dance, but they give you a different H and K and a different X and Y. So pause the video and see if you can get that one. And we'll start with the center, H and K. Here the H value is negative, so this will be X minus a negative, so this will turn into a plus 4. Our K value is positive 11, so that would go there. And I'll switch over to blue. Our X is negative 6, so this is negative 6. Our Y value is 15. And don't forget, we're solving for this unknown A. So A is going to get multiplied by this. Negative 6 plus 4 is negative 2. Negative 2 squared is 4. So that becomes 4A plus 11 equals 15. If we subtract 11 from both sides, 15 minus 11 is 4. Here, nice and easy, divide both sides by 4. So A is 1. So I'm going to leave here, erase this. So we did that work to solve for A is 1. So this A is a 1, and we don't even really need to put it there because 1 times anything, it doesn't change anything. But let's finish off our equation. Remember, this is always going to be X and then minus our negative 4. That did change to a plus 4 and plus 11. So our equation f of x equals, and let's get rid of that 1. I guess the implied, we don't need it. Get out of there. So our quadratic function in standard form with the given vertex passing through the given point, x plus 4 quantity squared plus 11. Now there's an easier way to find the minimum and maximum value. If that's all they're asking for, we can use the idea that parabolas open up or down to figure out if we have a min or a max, and then there's a shortcut even to find the vertex. And the book says many applications involve finding the max and min value of a quadratic function. By completing the square within the quadratic function, we can rewrite the function in standard form like this. So here they do a little quadratic formula magic on that. So we can find the vertex of our function like this. Remember, our vertex is always going to be a point that we can graph. And we can find the x value. That's just negative b over 2a. Remember, in the quadratic formula, we would identify our a, b, and c. So here we do negative b divided by 2a. That is our x value. To get the y value, we're going to put that value back in the function. So for here in the book, they just say this is f of whatever that value is. So let's say we're solving one of these and we find this x value is positive 2. We would put the 2 back into this quadratic equation to find out what y value we pair it up with, so when we graph it. And now that's all explained here in the box, the official min and max value of a quadratic function box. Consider this function ax squared plus bx plus c. Its vertex will always be at negative b over 2a. And once you have the x value, plug it back in here to see what comes out. That's your y value. So there's your vertex. If your a value, if the leading term is positive, remember, if it's positive, your parabola opens up. If a parabola opens up, it has a valley, and at the bottom of that valley is your minimum. So that would be your minimum value, whatever that x value is. Or no, the minimum value at that x value. To find the minimum value, you'd plug it in and get the output. On the other hand, if the leading term is a negative number, remember, if it's negative, the parabola opens down. If it opens down, it's a hill, and on the top of the hill is a max. The max occurs at that x value, and the max value is, the output at that value. Let's check out this one. It's about a baseball, hitting a baseball up in the air. The path of a baseball after being hit is modeled by this function, negative 0.0032x squared. So it's negative and it's x squared, so it is a parabola opening down, plus x plus 3, where f of x is the height of the baseball in feet, and x is how far the distance is from home plate. Okay. So let's see here. I'm just going to underline this in red. Here's, well, our A value. Remember, we need A, B, and C if we're doing the quadratic. So here our A value is negative 0.0032. Our B value is 1. And we don't need the C value for this. If I go back there, remember, it's just negative B over 2A. Oops. So working on this one. Since A is less than 0, this is a negative number. It's a negative 0.0032. A is less than 0. We are going to have a maximum. This will lead us to a max, and that max value is going to occur at negative b over 2a. The x value, negative b over 2a. So we have a negative out front. Our b value is 1, and then down here we have 2 times a. So this will be 2 times a negative 0.0032. So this negative, let me switch over to blue ink, this negative and this negative will multiply to be a positive. And our numerator is just a 1. And down here we have 2 times 0.0032. That is 0.0064. 0.0064, and it's usually bad manners to leave decimals within fractions. So if we punch that in the calculator, it does turn out to be a nice 156.25 feet. Now, if I go back to the setup to the problem, it says here x, what we just found, is the horizontal distance from home plate. We're trying to find the maximum height of this baseball hit. So here's the player, got the bat, hits the ball, and the ball is going to go up and come back down. We know it has a max out there somewhere, and what we just discovered, that max occurs 156.25 feet away from home plate. So this distance is 156.25. Now we want to find the height, and this also will be the symmetry of our parabola, the axis of symmetry. So now we know the x value where this max occurs. Now we want to find what the actual height is. So we're going to take that same x value and we're going to put it back into this equation. Now this you're definitely going to want to do on a calculator. If we're in class together, we would do this on the TI-89. But this will be f of 156.25, and you're going to type it in as a negative 0.0032 times the quantity 156.75, that's squared, plus 156.75 plus 3. So back up here to our original quadratic, I just took out the x's and replaced them with the 156.75. And beep, beep, beep goes the calculator, and we get approximately 81.125 feet. So back to my crude picture, the height of this ball, we know that the max occurred 156.25 feet away, but now the height of it up in the air is 81.125 feet. Okay, that was fun. Let me go back, just double check real quick. I want to make sure I answered everything in the directions. Okay, what is the horizontal distance from home plate? Max height of the ball. I guess we got it. When I didn't see the book has a graphical solution provided. They probably just, graphed it in the TI-89. So if you went into the Y editor and typed in this function, you would see the parabola opening downward. And I'll show you in class there is a very slick way in the pull down menus to find a maximum value just by using the graph on those TI-89s. Here it just says rework example 5, but now the path of the baseball, a different batter come up. Everybody's going to hit the ball different. Every time a batter goes up, they might have a different function that would model that particular hit. So let's say here in this huddle, another batter comes up and they have they hit the ball that's modeled by this function. So go through the same thing that we just did in the example and find the same values or similar values for this batter. You didn't pause the video, did you? Okay, our A value, negative 0.007. Our b value in front of the x is a positive 1. Our parabola is negative, so our a value is negative. It's going to open down. So our a value is less than 0. That means the parabola opens down. Open down. If the parabola opens down, it's a hill. On top of the hill is a max. Max, there we go, max. So where does this max occur? At x equals negative b divided by 2a. Our b value, well, we got negative out here. Our b value is a 1. And then down in the denominator, 2 times a, our a value is negative 0.007. So just like in the example, this negative and this negative will multiply to a positive. So our x value is 1 divided by 2 times 0.007 is 0.014. If we type that in the calculator, x is going to be approximately 71.4286 feet. So again, this is the distance away from the batter's feet at which the max will occur, 71.42. So I'll draw a different batter here in red. This max will be at 74, so that'd be even roughly half. This batter's ball is going to go like this. And we'll see how high it goes. I just drew them at the same height. I'm sure the height's going to be different. We will find out shortly. So here is the x value. Again, this is our vertex. So this is 71.4286 comma something. Comma something. Put a question mark there. So how do we find the y value that is paired up for this x value? We put it back into the original equation. So here's our original equation. We would have negative 0.007 times our 71.4286, that number squared, plus 71.4286, and then at the end, don't forget we got a plus 4 on there. And when we punch that in the calculator, we get approximately 39.7 feet. Did not go quite as high. 39.7. That one went 81, 39.7. So this red one should be more down here, not quite as high, won't go quite as far. Okay. So a little summary of this section from the first video and the last one. One, state the that's not a summary of it. They're just asking you to state stuff. So there we go. Okay, the homework assignment, pay no attention to this. That's from an older, so before we got our new books. Look for the assignment, of course, on Microsoft Teams or on WebAssign. See you in the next video.